Welcome to Transmission Podcast. I'm your host, Cecilia Lynn Jacobs. For the next little while, we invite you to speculate on the possibility of life on Proxima b, the closest known planet outside of our solar system that has the potential to support life. In each episode, we question what would happen if we suddenly knew we were no longer alone in the universe, and what that would mean for humanity to become an interstellar civilization. Please, stay close.
The one thing I learned over the years is that nature is much more imaginative than we are. We tend to think highly of ourselves, and we tend to be arrogant, thinking that we can predict what nature is about. But as far as I can tell, the most exciting things that we discover are things that we have never imagined. I should also point out in this context that very often physicists do experiments, for example, the Large Hadron Collider. You collide two beams of particles, and you sort of expect to detect the outcome. You have a huge amount of noise and signal there, but you are looking just for what you are expecting, and that's very dangerous. If you are restricting your attention only to things that you are expecting, you will never discover something completely out of the box.
That's Avi Loeb, a Harvard astrophysicist and an advocate for imagination. It's important to keep his advice in mind for today's episode. We're talking about how we would organize ourselves if we were to discover something completely outside the box, the presence of an extraterrestrial civilization. Cecilia Lynn Jacobs. Space is a noisy place. And we receive signals all the time. Everything from energetic waves on the electromagnetic spectrum to the sounds of gravitational waves. Oh, if you haven't heard about how we listen to space yet, go back and listen to episode 1. It's easy to dismiss a signal as nothing more than normal space noise, or to get overexcited and confuse normal transmissions with extraterrestrial communications. SETI, the Search for Extraterrestrial Intelligence, has a set of protocols for confirming a signal, but there is nothing that requires anyone to follow them. But we're getting ahead of ourselves. First, we have to receive a confirmed signal at all.
I guess the tricky thing with looking for transmissions, is the question of the strength of the transmission. If you were transmitting isotropically, like so if we're sending a signal out in a spherically symmetric way, like how a star shines. It's not actually how if you had a radio transmission, you wouldn't be sending it out in a spherically isotropic way, probably. But if you did, the strength of that transmission decreases as 1 over the distance it goes squared, 1 over d squared, right? So this is just the inverse square law. And so that means it gets fainter really fast. Really fast.
That's Dr. Beth Billar from the Royal Observatory at the University of Edinburgh. While there are some significant challenges to detecting a transmission, let's speculate. Let's say a signal does get to us. What do we do? Our next step is to confirm that a signal really does come from extraterrestrial intelligence.
So my name is Dr. Duncan Forgan. I'm an astrophysicist / astrobiologist, currently based at the University of St Andrews. The detection process has many stages. First of all, you see something you don't understand. You then have to try and rule out whether it's a problem with your instrument, whether it's a problem with the way you've taken the data and analyzed it, whether it's something man-made. So, for example, we often see signals that look like SETI signals, but actually are produced by terrestrial broadcasts that bounce off something nearby. So like a nearby satellite might reflect some of that signal back to the Earth, and it looks like maybe it's something like an extraterrestrial transmission. So you have to go through this process of kind of checking that you've done it right and that you've not just seen a ghost in your apparatus, you've not just seen a bug in your code, and you've not just seen something bounced off a satellite. So you have this process of checking everything.
I think that the public has this idea that these kinds of experiments are run by people dressed in white lab coats for some reason. I'm not sure why I'd wear them. They're not all that attractive. But anyhow, sitting around white lab coats with clipboards in their hands, with earphones on maybe, listening to cosmic static, hoping to hear a radio transmission from the aliens. Well, that would be a really boring job because we listen to 40, these days, it's 40 million channels simultaneously. So that would be 20 million pairs of earphones, and that would definitely mess up your haircut. So we don't do that. They're all listened to by computers.
That's Seth Shostak,
senior astronomer here at the SETI Institute. That's SETI, Search for Extraterrestrial Intelligence. And we're located in the Silicon Valley of California. And the Institute is interested in life in space. And amongst its many experiments to look for life is at least one to look for intelligent life. And that's the project I'm involved with. So we're trying to eavesdrop on the aliens. I've been doing this for a while. And before that, I was a radio astronomer studying galaxies. But you find signals all the time because, there are telecommunications satellites orbiting the Earth and stuff like that. So if you found a signal, the first thing you would do is check it out as much as you could. And if you checked it out and were still convinced it looked like it was real, you'd probably call up somebody at another installation somewhere and say, hey, you guys check it out, because you probably wouldn't want to announce to the world you'd found ET if you really hadn't. So you'd want to have it checked out. That would be the first thing you'd do.
Gotcha. And how would we go about checking it out? Like, what would we look at? What are we interested in?
Well, I mean, what you're interested in finding out, that signal that these guys are claiming, is it really coming from the sky? Or is it coming from, a local airport or just a satellite that happened to be passing overhead? So you would just tell somebody at another radio observatory, which is to say somebody with another big antenna, and you would say, look, Bob, we know you're busy, but how about aiming your antennas in this direction and look at this part of the radio dial and see if you find the signal too. And if they don't, then you've got a problem with your own setup. But if they do, then I think you can feel fairly confident that you're going to be invited to Sweden in the future to collect a big prize.
Clearly, this is a big project, one that requires many brilliant minds who are willing to work together. Anyone who's been involved in a large-scale project before knows that collaborations on that scale come with their own unique set of challenges. We spoke with Aaron Zimmerman about the recently discovered evidence of gravitational waves. This was also a difficult, lengthy, and expensive project, but this kind of project could perhaps serve as a model for the future discovery of alien life and the resulting scientific collaboration.
We're on to the question maybe of how to organize listening, and I think this really depends on how challenging it is to listen. That really sets a lot of things about how you do it and what your standards are for analyzing your data. So these days we are entering into an era of big collaborative science in every aspect of science, at least in physics and astronomy. So to do something totally new like detect gravitational waves, it really requires $1 billion and 1,000 people working for 2 decades. And that, of course, changes how you finally analyze and present the data at the end of the day, right? You really have a high burden of putting together something very convincing and very clear and doing a lot. Now, of course, individual scientists generally, right, we work hard, we want to present good results, analyze them thoroughly. They need to pass peer review, but also that's not even the driving goal. People don't really these days, I think, put out papers that they don't think are going to pass peer review. Most of the time they put out papers that they have passed their internal standards, and therefore they will pass peer review. But if you're working in a faster field, if you're working in a field where smaller teams can utilize big telescopes or resources or things like that, or even when you don't need big resources, then people can be a little less careful. And they kind of need to be sometimes because they're in a very competitive field, right? If something happens in the universe and both you and I have telescope time that will allow us to investigate this cool event, one of us can't just sit on our hands while the other person does the analysis and produces the results and gets to say, I discovered whatever. So sometimes fields can be quite competitive, and then you have to work faster. So that's I guess the answer to the question of, is everyone so careful? I mean, I think everyone tries to be careful, but sometimes you sacrifice thoroughness in order to make sure that you get your ideas out there in a timely manner. The bigger the collaboration, the more people are going to be thorough.
We do have a set of suggested protocols for the discovery of extraterrestrial intelligence. Breakthrough Initiative's Pete Warden summed up the process.
Well, of course, the postulate is that presumably in some time our program or a related one in the next several years discovers a signal. We've done a fair bit of discussion about how we would work that. There is an existing international organization. It's the International Academy of Astronautics SETI working group, of which most researchers that are working on are members of this. We've been using that to coordinate when there's a potential signal. So the first thing that happens is if there's a signal, we communicate to other people on the working group and people that have different instrumentation. So the next step is to look at the potential signal with as many different, radio telescopes, optical telescopes, other instruments that we may have. The first thing is to contact the members of the working group, and then very soon you would contact other institutions and observatories that have capabilities. After that, of course, we have to figure out what the significance of any detection is. The more data you get, the more significant it is. There is a scale, a scientific scale called the Rio scale that goes from 0 to 10 in terms of the significance, where 0 is not significant. So if we started to get something that was, 3, 4, 5, the next step after getting the data would be to convene some more intensive working groups to try to assess, again, to prove this is a real intelligent signal and how do we expand on looking at it. There hasn't been a lot of discussion about what the organization might look like, but I think in the end it would be a ad hoc organization, probably under the International Academy of Astronautics.
With these suggested protocols in place, we might be able to effectively organize, but will we give up speed for accuracy? Will a discovery like this wait for good science? We'll look deeper into the next steps when we return. Stay close. Welcome back. We're trying to understand how we might organize around the discovery of an extraterrestrial transmission. We know there are loose protocols for confirming the signal, but many factors come into play when thinking about what might happen next. We spoke to Pippa Goldschmidt, who speculated on this complexity.
I think, at least in the first place, astronomers are good, like you said, at sort of coordinating their work sort of around the world. So at least in the first place, it might be something like when you get something like a supernova, a really bright transient source that you really need to capture information on quickly, so that you tell astronomers around the world to just sort of swivel around and look at this object. So I imagine, at least sort of on a very basic level, astronomers working at telescopes would be told to sort of focus telescopes on a particular part of the night sky to try and get as much information as possible at the time, so that you'd know when this thing would have been broadcasting, and you'd know where the broadcast was coming from in the night sky, so you get as much information as you could to try and work out, say, maybe what type of planet it's being broadcast from, or what type of object. I'm assuming it's planets, but it might not be. What type of object's doing the broadcasting. And then you'd also go back through your archives and look at all the historical information that you had on that part of the sky to try and work out whether it had been sending you stuff in the past and you'd missed it. So perhaps you'd already received information from this artificial intelligence in the past, but we just hadn't managed to sort of understand what it was. So it's a matter of perhaps doing a little bit of sort of archaeology, if you like, going back through the information that we have. And we have astronomical information now going back like nearly 100 years in some ways. So that would be part of it too. So that's a kind of very basic aspect of it. In terms of the more sort of sociological, how do we organise ourselves? That's a huge question. I mean, I can imagine like governments sort of, falling over themselves, or trying to work out how to respond. And of course, the different governments would want to respond in different